Let us show you the load balancing of 4GL applications with Kubernetes. First of all, we create a cluster for running containers in Google Cloud using the Google Kubernetes engine. We use a default configuration and specify the cluster name and location. Then, we fetch the cluster credentials to manage the cluster on the local machine. Next, we have to create a disk where we will deploy our application. We select the 10 GB option. Once it is created, we deploy the NFS server container for it to run in the cluster. In its basic configuration, we specify ports and file system type of our volume. Next, we create the NFS service for our cluster with the following configuration. Then we create a volume itself, which we are going to use for application deployment. Here, we specify the capacity and the access modes, and link this volume to our NFS server container. Now, let's move to creating Lycia runtime containers, which will serve our application. At first, we create a secret for our Docker Hub credentials and deploy our Lycia container. In the configuration file, we specify its name, the volume to attach, ports, and so on. Next, we create a load balancer service to distribute the incoming requests evenly across Lycia runtime instances. In the config file, we specify ports and session affinity types. We finish with a horizontal pod autoscaler service. Its purpose is to run new Lycia containers once the incoming load reaches a certain limit. In the configuration, we specify the minimum and maximum number of replicas and the memory utilization metric. So, let's check the dashboard of our cluster. In the dashboard, we can observe the number of running replicas and the information about memory utilization. If we switch to Google Cloud's Kubernetes Engine console, we can observe that same data, including the number of running pods and host IP address. Now, let's start an instance of our application and check the processes of our container. Here, the cron process is running, and the memory utilization starts to grow. Let's start another instance of the application. A new cron process appears. Next, we start more instances of the application. Once the memory utilization reaches 600 megabytes, a new container is created and is ready to serve new incoming requests. The Google Cloud Console also shows that there are 2 containers running. In the dashboard, we can check the status of the running containers and memory utilization. To make sure that the previously started applications are still running, we check the processes of our first container. Let's start a couple of new application processes and check that the application responds to our commands. If we refer to the processes view now, it will show that the second container is serving the incoming requests. Next, let's start a few more instances of our application and verify that the corresponding cron processes are started on the second container. We can also check the memory utilization for each of our containers. So, both of the containers, the initial one and the new one, are serving incoming requests. Lycia offers integration of your 4GL applications with many prominent, most modern technologies. Visit Querix.com and drop us a note to embrace the future of 4GL.